I'm going to talk about lawful interception in German voice over IP networks. And I'm with an ISP that has enough customers to actually apply to all those laws. So starting next week, we have to comply to all the regulations that the German government imposed on us. So since voice over IP itself is kind of new, there was pretty much a new company where you can just buy something off the shelf to get the job done. So we had to look into that on our own, and there was a bunch of approaches from various companies adopting their email solutions to the whole problem. And coming from that, I'm going to talk about what's lawful interception and how is lawful interception done in PSTN network, since it's in place in PSTN networks. And if you read the German Verfassungsschutzbericht, it's like a yearly report of the German law enforcement agencies. And you can see that there are about 27,000 so-called Maßnahmen, like expulsion orders each year in PSTN networks. So some of that applies to voice over IP. And we're going to see lots of orders and regulation in voice over IP networks. And I try to find some of the countermeasures, since sometimes lawful interception has to be done. But yeah, you might want to be able to detect if you're being intercepted. And the government, as I said, is kind of new to the whole issue. So when they first came up with the idea of being able to intercept voice over IP, they said they want to do everything. But yeah, soon after writing the initial thing, they found out that it's not that easy to actually intercept data in IP networks. So they came up with an interim solution that's easier to implement, but nonetheless, we have to get the whole thing done, including media interception, like that's known from PSTN networks. So I'm going to talk about upcoming nightmares. So what's lawful interception anyway? Okay, it's basically just spying on users. It's justified by the government, since you've got some basic law in your country saying, okay, the government or some government agency is allowed to spy and get data from a certain user. And obviously the goal is gaining information of all sorts. It's not just the email content, but it could be a relationship, like you're sending that person an email, or that guy has been calling you on a weekly basis. That's information you can use to actually do the well-known German Rasterfahndung, like building relationship diagrams and see if you can find somebody who has been under your radar, but has been in contact with a lot of people that are already being intercepted. So if you find new persons, you might want to deeply look into that and still do regular surveillance. And it's not about content, just relationships. And the target could be anything. It used to be just a phone number, email address, and more DSL ISPs, access ISPs that are providing internet access have to copy all the data, all the IP data somebody's doing to a law enforcement agency. And yeah, since the PSTN law has been modified to also apply to voice over IP networks, it also applies to zip addresses, like phone numbers being used in voice over IP networks. And all these kind of account information are named IRA. It comes up in some of the RFCs. I'm quoting just one of them, since there's no real RFC on how to do lawful interception. Since although we've got a European standard that's being written right now, there's no worldwide standard that could fit into an RFC. But you're going to see that in that term sooner or later. So being in Germany, we've got a lot of amts and everything and agencies dealing with all this stuff, and we've got lots of funny terms to name all these agencies. Like we've got the Bedarfsträger. It's just a law enforcement agency, but Bedarfsträger just sounds way better than your local police department. And it's then we've got berechtigte Stelle. A berechtigte Stelle is an entitled agency that is allowed to demand data from a company that can start one of the expulsion orders. Like, okay, now you've got 4 hours time, you have to start copying data to us. And everybody who's allowed to do that is called a berechtigte Stelle. And the interception process itself is just named Maßnahme. A Maßnahme could be lasting for just a few hours, could be a couple of years, could be anything. So in the handshake process, where somebody actually starts a process, there's so many problems that one of those interception processes could actually last several years, although it should have only lasted for a couple of hours, since you're not allowed to see who is currently being intercepted. So there's a big issue with that. And then we've got the term Ausweisung. Ausweisung, yeah, sounds kind of funny. Nobody knows what's meant by that, but it's just the process of copying data and sending the data to a law enforcement agency. And later on, you're going to see active and passive expulsion. It's depending on the way on how you actually get to the data, to copy the data to the law enforcement agency. And we've got just one law dealing with all this stuff. It's called Telekommunikationsüberwachungsverordnung. And it says, oh, great, you've got a PSTN network. So you've got to be able to copy data to us if we demand the data from you. And it's called TKÜV, or ÜV, depending on how you actually spell it. And it just says, okay, you have to be able to copy data. And nobody's, okay, how am I supposed to copy data? Am I going to just put some data on a floppy or a CD and just send it to some place, Bonn, Pullach, whatever? No, we've got a technische Richtlinie zur Telekommunikationsüberwachungsverordnung. It's just technical guidelines. It says, okay, if you're copying data, you have to encode data in a certain way. And you have to apply to some mechanisms or use a certain VPN or whatnot. And then you've got the Durchführungsverordnung, since nobody knows who's actually allowed to send one of those expulsion orders to me. So somebody just calls me up and says, okay, you have to copy all the data from my former girlfriend to my email account. I want to get all the information. But yeah, who's allowed to send that? So you've got the rules of conduct dealing with all the so-called handover interfaces, like management. Who's allowed to have physical access to the box doing all the copying? Who's allowed to set up accounts or set up the Maßnahme itself? And who has to take has to read all the logs and make sure that no additional kind of test expulsion was added. Like somebody was just testing the equipment and just copying data of his friend. So you've got a Durchführungsverordnung, which is taking care of most of that. But it's all dealing with PSTN. And the government just said, okay, those laws should apply to the voice over IP world in the same way. And early on, they figured out, okay, we just cannot apply the very same laws. So being in the European Union has a agreement called ETSI, the European Standards Institute, and they are about to release another law or kind of set of rules on how to do lawful interception in voice over IP networks. And our law is going to be changed, which just reads, okay, you have to comply with the European standard, and that's all you have to do. And there's a few parameters that you might be able to change depending on your government. But we are still waiting for the Überwachungsverordnung to be changed to meet the European standard. And the European standard has still to be written. So for now, we have to stick to the PSTN network and just apply the very same rules to voice over IP networks. So this is your typical PSTN network. You've got 2 phones, any kind, could be GSM, could be your standard PSTN phone, connected to some PSTN switch, and you've got your PSTN network in the middle. So if you have to copy any data, all you have to do is to just set up the expulsion process on one of those boxes, like one of the black boxes, the switches. Most of the boxes actually have everything built in to get the process started. All you have is some direct connection to the so-called berechtigte Stelle, like the law enforcement agency. And if you can't afford, if you've like thousands of points of interconnection or all the local area codes and multiple POPs and everything, you don't really need to have all the means to copy data in every POP, since you can just redirect traffic. Like if you don't have the means to copy data on the left switch, you would just forward the call to the right switch on the right side, and that would have all the hardware installed, and just copy the data on the right side, and nobody would know, since you can't do like traceroute or measure round trip times. It's easy to do, and it's in place, and it just works. So why does it work? You've got signaling and voice in parallel. Like the way your signaling is traveling, like the person you're trying to reach, is the same way your voice data would flow. So once you get hold of the signaling, you can get hold of the voice data and everything, or could even be like IP data or some encoded stuff in the data channel. And in old systems, you even had in-band signaling. Like you just had 2 wires, so it's really easy to copy data on that. You just have to get physical access at some point. And as I said, you can just do lawful interception on the upstream gateway. It's really easy. And yeah, you can't ping round trip times. You can't do ping and see, okay, this call took me, the round trip time on this call was like 20 milliseconds, and sometime you get intercepted and it's 50 milliseconds. You can do that, but you usually have to have some really expensive equipment called like SS7 analyzer, and you have to have access to the network itself to see most of the stuff. You can try to do some stuff on your end device, but there's no easy way like traceroute. You just do traceroute and say, okay, my previous call didn't go to that gateway, but now it's going. All my calls are now being redirected to like Berlin or Bonn. There might be something fishy going on. So VoIP should have all the PSTN lawful interception features. It should be undetectable by the user. So if you're getting intercepted, the law enforcement agency likes to see some information. But if you see that you're getting intercepted, you might order pizza or something, but yeah, you won't talk like you talked before. And the handover interface, like the management, who's allowed to actually order you to do something, should be the same, since the government knows how to deal with that, and there's interfaces in place, they know how to do this stuff, so they just wanted to make sure that everything still works. And security. Nobody was able to actually attack PSTN hardware, since you don't have, you can talk to some box, but you can punch in a phone number, but you don't really have like IP-based access to your PSTN gateway. And it was really hard to get hold of PSTN hardware. But with voice over IP, it's easy. There's an operating system running on your soft switch, and you can just attack the underlying operating system and then try to modify your soft switch. So they wanted to have the very same kind of security. So, but everything is different in voice over IP. We've got different signaling protocols, like the kind of standard zip. We've got AS323, and we've got Skinny, the Cisco call manager protocol, which is just used on kind of smaller installations inside companies. And I'm just going to focus on zip. And for media, we've got lots of different codecs. The standard GSM codecs and PCM codecs that you would see in most applications. But then there's open source codecs, high bandwidth codecs, optimized for high bandwidth and good quality applications, stereo with not mono but stereo. Then you've got other codecs optimized for high latency links and everything. Then you can have something like Skype, which might use a completely different protocol. But still, at some point you have to be able to copy all the data. But if you don't know what codec you have to use, you might not be able to apply all the very same tricks you used to do on the PSTN side. So how does a simplified VoIP setup look like? You've got one zip proxy in the middle, and you've got 2 zip clients. And zip client A tries to reach zip client B, and it sends the zip invite message to the zip proxy, which then just forwards the message off to the second phone, since the zip proxy would just know the IP address of the person you're trying to reach. But once you've sent all the messages, your voice data would be flowing just between those 2 clients, just to keep the bandwidth away from the proxy. Reduce latency, delay, everything, it's just make it work. There might be some net issues, but generally, this is the way it was designed. But a more complicated and more common setup would look like this. You've got a bunch of clients talking to your zip proxy, and then the data flow between just the voice data might be just flowing between 2 clients. Then you've got, might have some announcement server, like for regular service announcement, like you're not allowed to do that call or something, and then you might have pre-call announcements, like the next call going to cost you like 10 cents a minute or something. And if you're dealing with NAT, you might have a so-called media proxy, which acts as an intermediate host, like an HTTP proxy, and allows you to traverse nuts you won't be able to traverse without having the media proxy. But you have two media flows going in and out of the media proxy. You might have, which I didn't picture here, like voicemail applications, like IVR systems that you can send voice data to, or DTMF tones, and that will respond to you. Then you have PSTN gateways, which convert your RTP traffic into something that's going to end up as a PSTN call. And then you've got zip peering partners. You're going to talk zip to the peering partners, but nonetheless, the RTP data is directly flowing between those two clients. If one client is just signed up to another zip domain, you don't care. So there's hardly a point where you can actually get RTP and zip data, but near the client. So the first attempt to actually get zip data and RTP, like voice and signaling, was, okay, let's just, if you're getting intercepted, just build some sort of conference call and just make a phone at the law enforcement agency, just ring, and they just get a copy of your signaling and your voice data, but it has to be implemented in the client. And nobody would do that, since in zip and in just doing TCP dump, you would see somebody's getting a copy of my data. And you might not have the bandwidth to actually do that. So that's no way to do that. Media gateway. Like I said before, if you're having any net issues, your call might already be directed through media gateway, which has an external IP address and is able to talk to both clients and to clients that wouldn't be able to talk to themselves before. So you just divert both signaling to your proxy, which is already flowing there, and just divert media towards that media proxy. But you have to modify signaling, and that doesn't comply with one of the first laws, since the user should be not able to detect that he's getting intercepted. So on the other side, it's easy to implement, but it's easy to detect. There might be some ways of confiscation, like in a regular environment, like every 10th call might be directed to random media gateway, like you have like 100 media gateways, and every 10th call is directed to a media gateway. So that's your normal behavior. And if you're getting intercepted, suddenly all your calls get diverted to a media gateway. But since the chance of getting directed to a media gateway was like 10%, you might not notice on the first attempt, or probably takes you 10 attempts to actually see, okay, I'm getting redirected to a media gateway every time I place a call. So you might still figure that out, and as I said, you can still see that something is being replaced, but it could be just to the regular setup. And some ISPs, and even in PSTN setups, usually have an IP address in there that's not your own and not your callee IP address. So you really have to have a look at the IP address you're seeing, since somebody might have replaced the IP address in the signaling without having you knowing, but it's just a regular setup. So on the other side, it's no way, since if you're using codec like Skype does, that's not supported by your media proxy, you might not be able to actually forward the codec. So that won't work. The next attempt that was done on various things, and the German cell phone ISP actually did that, was just diverting calls into the PSTN. Since if you're not able to intercept a call in the GSM network, on the voice network, but you've got all the equipment in place in the PSTN network, why not just use the equipment you've got in your PSTN network side? What you do is you just divert your signaling to the PSTN switch, and just kind of replace the phone number. Say, okay, that call has to go through the PSTN network, and the first PSTN switch then says, okay, it's a voice over IP number, just send it back. So it kind of loops through your PSTN side, and you can use your PSTN equipment. But on the downside, there's some features in zip that cannot be done in PSTN. And on the other side, you've got PSTN features that are not present in zip. So you have to translate all messages from zip to PSTN protocols and back. So there's an extra delay, and you can usually see that. You can see that you're getting diverted to another PSTN gateway. It just looks like if you're directed to media gateway. And the same rule applies. You might not be able to do all the codecs, There's a limited set of codecs available in the PSTN side, and PSTN gateways usually just support a really limited set of easy to decode and code codecs just to save CPU power. So voice quality might be worse, since you're translating all your media packets on the zip side into PSTN media and vice versa. So you might actually hear a delay, voice quality might be worse, so that won't work. Then there's something called passive Ausweisung, which is actually favored by a bunch of companies, since most of those companies come from the email approach, since they had to do all the law enforcement for email, like copying emails, and you usually have just a limited set of mail servers, and usually an email ends up on just a limited set of systems. So their approach was just every POP where you have those PSTN switches or voice over IP switches, you just add an interception point called IAP in the RFC, and you'd be instantly able to copy everything your customers do. So the right thing should be among that. But you've got all the equipment in place, and if somebody wants to get in, do an expulsion process, he would say, okay, you've got everything in place, so just get started. If it's really hard to get started in first place, judges might think twice about just ordering something like this. So it's generally a bad idea, and we've seen a few setups just on just paperwork, which look like, okay, you have to have 18 rack mount units worth of equipment running Windows at some POP just to get it done. And then you have to deploy another 4 or 5 rack mount units in each POP you have. That's probably like $30,000 of equipment for each POP. Lots of hardware to take care of, and it's an easy target for hackers. It has IP-based access. It's in place there. Nobody wants to. No, sorry. Nobody wants to deal with that, since you have to do it. You have to comply with the law, but you don't get anything for doing anything more than just comply to the law. So you just put it up and don't care about it. But yeah. Other people might think it's interesting, and you might be hit by a rootkit, you might be targeted by a specific attack, and it's not worth it. It's just overhead. And who's doing all the management, like updates, patches? You have to if you comply with the law, you have to have a secured rack space. You have a limited number of people who are actually allowed to administer the system, do upgrades, and all that sort of stuff. So it's just overhead, and it's really expensive. But on the other hand, it's easy to get the data, since you've got everything in place. So the other way around is you don't have anything in place, but at some point you've got a stock of system that you can use to get the job done. And if somebody calls you and says, okay, I'm verified to get you, make you drive to the POP, install hardware, you just go there, install the hardware, and once the expulsion process is over and the law enforcement agency is happy, you just remove the hardware, but it might take some time. And Germany is kind of small, but it still might take you probably like 2 days to get everything in place and tested, since you have to set up a dedicated line to the law enforcement agency. You have to attach to a VPN. You have to get routers in place, the so-called Xena boxes, which is just like a Linux-based VPN tunnel. But you have to get IP addresses, and it's kind of a hassle, and it's visible. Like if you're entering the POP and you're seeing the specific devices in the rack, probably not mounted properly or something, you see, okay, somebody's getting intercepted right now. And what happens in long-term surveillance? So now you have like 20 different POPs, and in each POP, somebody's getting intercepted. So you end up having expulsion orders that last for like 2 years, and sometimes, at some point, your temporary hardware turned into permanent installation. So you have the passive approach over again. And how about roaming users? So think of a guy using a voice over IP account, living in like northern Germany. He's signed up in northern Germany, so you're driving to northern Germany with all the equipment, mount the equipment, and a day later he drives off to Berlin. So you have to disassemble everything, get it in place in Berlin. So it just doesn't work. So any ideas till now? Don't do lawful interception at all? Yeah, that won't work. And one of the interesting approaches was voice over IP is not just, you don't take voice over IP as a PSTN replacement, but it's just a service on top of your ISP, on your access ISP. So just make your underlying access ISP like Deutsche Telekom, if you got a DSL access, sniff the data and copy the data to the law enforcement agency, since both signaling and your voice data would be in there. But voice over IP ISPs, and there was a talk before on this, are trying to make voice over IP a real replacement for PSTN. So on the downside, we also have to take care of all the law enforcement things that we have to do if we want to replace PSTN. If there's no PSTN network at some point, we have to have all the means in place to provide the same access to the data. And you might hope that the German government writes readable laws or instructions, like what are you supposed to copy, how those things authenticated, what's the maximum latency that's allowed, since one of the usual use cases for lawful interception would not be getting voice data, as I said, but it's just getting signaling information. Like somebody's in his house, there's a SWAT team in front of the house just waiting for the person to be busy somehow so they could enter the house. So they were just waiting for the person inside to pick up the phone or answer the phone, and he's busy talking to the phone. So that's the point where you could enter the building. But if it takes you like 5 minutes to actually get the data to the people in front of the house, he might already hang up. So that's one of the things that we have to make sure to provide the data as fast as possible. But voice over IP is kind of new to the government, and as I said, they first said, okay, voice over IP should be as easily accessible for us as is PSTN. So just get started on that. And later on, I think it was kind of April or May, they sent around a few letters asking questions. Okay, what are you able to do? Do you have anything in place? And are you able to copy all the voice data? Are you able to copy signaling? Are you able to modify this? How are you actually doing this or that and all that kind of stuff? And yeah, you had to respond. And at some point, they came up with the consents and said, okay, we're going to do an interim solution. That's actually one of the next slides. So I'm going to go to that later on. But they first have to come up with the idea of what actually to intercept, since at some point it doesn't make sense to blame everything on a voice over IP ISP if two persons, probably one sitting in Australia and the other one in the US, are talking to each other using voice over IP from a German voice over IP ISP. But one of them is using a Telstra cable modem in Australia, and the other one is like on Comcast cable in the US. And we don't have access to any of their voice data. So how are we supposed to get the voice data? Are we supposed to put in a media proxy that's easily detectable, and round trip times would be that much worse? So you don't have to have any equipment to actually hear that you're getting intercepted. So it's like so 80s, doesn't work. And the government is probably about to accept there are some calls that are untraceable for them on a voice over IP basis. So at some point, they have to agree with like the German, the European Union and the ETSI standards. So they probably know that they have to get to the access ISP in a different country to get the voice data if they have to. But that's still up to them. And then there's some countries that are actually outlawing voice over IP. They're not outlawing voice over IP just since they cannot really trace it. There might be some countries, but those are many of the countries where the PSTN system is actually owned by the government. So they don't want other ISPs to take the revenue streams of the government away and offer free calls over voice over IP. So they're just outlawing voice over IP and say, okay, you have to do everything using PSTN calls, and we've got everything in place on the PSTN side. So they are taking a completely different approach. But if you're doing anything, these are the things you shouldn't do. If you divert traffic from ZIP to PSTN, do not show the diverted calls in your so-called Einzelverbindungsnachweis, in your call logs, like, okay, you've placed the call from A to B, but B is not the person you called, but your law enforcement agency. And do not add cost announcements. Like if you're traversing your network edge, there might be some announcement like this call is like 5 cents a minute, and you usually don't hear that, but sometime you're calling a law enforcement agency and you now hear the announcement. Yeah, you probably know that something is going on. And do not bill the user for intercepted calls. That's happened on a German cell phone ISP. Some people complained about paying several euros a month for calls they didn't make. Since it was supposed to be a free call inside the GSM network, but it turns out it was a PSTN call, and they didn't make a PSTN call. And don't make it too easy to use. If you've got equipment in place everywhere, somebody just has to step up to a judge and say, okay, I want to get that person intercepted, and the judge will just sign on that, since the government is paying like 17 euros before taxes for each of those expulsion orders. So you have to copy data for like 2 years, and all you get is 17 euros minus taxes. And don't make it too permanent. Like, don't put hardware in your network that it's viewable to everybody, and it's just a security issue. The government might be interested in getting your data, but there's lots of other people who are interested in just playing around with either hardware or playing around with their friends and just get data from their friends. So countermeasures. You don't know if you're getting intercepted, but you like to know. And a good way to get that done is before you think you're getting intercepted, just start. Since right now there's no law saying that you have to be, or that ISPs have to be able to intercept you. That's going to change next week, actually. So just make fake calls and save round trip times, like the time it actually took to set up the call itself, the time it takes for the first media packet to get back to you, or the so-called record route IP addresses in your signaling, or the SDP header information, like the codec you've negotiated with your other side and everything. And if something changes, it might be some sort of media proxy or stuff, and it might be some government agency. And I'm not talking about systems that might be in place, and I'm gonna come to that later on, but just try to get data and see if things change. And the sooner you get started on how things look like in a regular state, you might be able to see how it looks like if you're getting intercepted or something changed. And another thing is you could just use random unsupported codecs. Like if you got 2 clients and you just change the line where it says, okay, I'm using PCMA law, and just say or rename the codec to read FUBA. And your other client on the other side says, okay, I support codec FUBA, since I know it's just PCMA law, you'll be able to place a call. But if there's a PSTN gateway in the middle, it might say, okay, I don't know anything about the codec FUBA, and I don't support your codec, so I'll just throw you an error message. And the moment you see that, you know that your call is being diverted to some media speaking gateway. So that might be a way to see what's going on. And if you've got some passive solution that tries to copy data, that might trip over that too, since if you're saying you speak some unsupported codec, that system might not figure out what kind of codec it is and might not know how to reassemble the codec. So think of that. And challenge authentication checksums are already in place for some of the signaling, just to make sure that you know how to build a call. But you can use TLS and SRTP to encrypt both signaling and media. And since you've got checksums, you can make sure that nobody changed anything on the way. But on the other side, your ISP might have to have access to all those data, since if you're placing a PSTN call and you're encrypting your voice data in your voice over IP network, but you're sending the call to the PSTN network, your PSTN gateway has to decode the call to actually convert it into something that's understandable in the PSTN world. So that might not work in all the cases, but as long as you're just doing voice over IP to voice over IP calls, that might work. And if you're using TLS or SRTP, that's fine with me, since from voice over IP ISP point of view, you still have to provide the data as far as you can. But if it's SRTP, it might be easier to just get access to the access ISP and get a copy of the encrypted data, since it's up to the law enforcement agency anyway to decode the data if they know how to. So just get started with TLS, and we might get rid of a few issues later down the road. If you want to play around and see how easy lawful interception could actually be with zip, you can just sniff at some point in your network and copy all the UDP data you see. Be sure to set the large snap length to actually get large packets. And then use Ethereal to reassemble the RTP stream. You're going to see all the signaling. You can do call flow diagrams and everything with Ethereal. And you can just right-click on a RTP pack and say, okay, reassemble that stream and save a WAV file. And you'll have a WAV file of a call you made or somebody else made on your hard disk. You can do all sorts of statistics like jitter delay and all that stuff. And it really comes in handy. And it's no lawful interception. It's kind of government safe, but it's really easy and nice to have if you have to debug stuff. Like if you want to know where some jitter or delay has been introduced, just do this on multiple spots and you see where the bad things are happening. So the PSTN law should have complied or applied to the voice solution or the voice over IP solution, but the government figured out, okay, that doesn't work, so we're going to get an interim solution that just focuses on signaling instead. And since from our questionnaires we sent to the ISPs, that should be doable. So they sent a letter in July and said, okay, there's something called ETSI TS, it's technical specification 101671, which is the standard on how to copy data. It's XML encoded data on how to just put single zip messages into XML files and copy them to a law enforcement agency using a VPN tunnel. And yeah, you got a paper, it was like 2 pages, just referencing the ETSI standard. And later on there was a meeting, and there was an earlier meeting, and people started questioning, okay, what's the maximum delay that I'm allowed to introduce to the system? Like, do I have to actually get hold of the packet and the zip message as fast as possible? And how long am I allowed to hold the packet on my network side before it has to be at the law enforcement agency? Like zip messages might be fragmented. So what's going to happen to fragmented zip messages? Since I might not be able to identify the second fragment of a large packet, if I don't have the first packet, since there's no username in the second packet, it might be just SDP information or something. So there was lots of things to talk about, and eventually the Bundesnetzagentur agreed to be kind of easy on that. So we still have to do something, and it has to be implemented by ISPs this year. So officially, nobody has this in place right now, and nobody would say that he has anything in place right now, since if you say out loud that you have something in place, your government might just step up to you and say, okay, since you've got this stuff in place, just let's get started. So that's not going to happen. But starting this weekend or next year, you're going to have that in place, and it should be ready for production use. So what are the issues with that right now? The interim solution is just based on zip signaling, and it's just based on account information. So you've got a username, a phone number, anything. The phone number might actually have different formats. It might be like 0049431 for a German Kiel-based phone number. It might be 043 for a German phone number. It might be something like plus 49431 for Kiel. So there's lots of issues, but what about zip messages that could be identified as being from somebody who has to be intercepted, but I'm not seeing his username in the zip message itself, but like in voice data or on other following zip messages. Like I'm calling my own voicemail box, but not from my phone, but from a friend's phone. And my friend's phone is not being intercepted, but nor is my mailbox, since my mailbox is not my phone number, but I'm calling a service number, which is not getting intercepted. And I'm just authenticating myself to the voice mailbox system by punching in my own phone number that's being intercepted, but it's not visible in zip. It's visible in zip some sort of, but it might not. And just punching in a PIN number. But how should the lawful interception system know if that PIN was right? And how should it reassemble the phone number that I just punched in? So there's lots of issues. And then you've got delay. So what's going to happen to defragmented packets, or what's going to happen if the VPN tunnel breaks down and all that stuff? And one of the most interesting ones is how should I make the whole process undetectable? Like, I'm not allowed to divert traffic, since I can see diverted traffic in IP, it's easily to see, and I can see diverted RTP media. But since we're not dealing with IP media here, this is doable in most cases. It's just been done, and most companies have to be able to do that, and it probably is just port mirroring on your Cisco. And the German government is not happy with the interim solution, and they have to comply to the European standard. And there's going to be an ETSI standard coming out sometime in 2006. And the German government, the Bundesnetzagentur, will just apply the European law, and just say the European law just applies to Germany, and probably makes a few minor modifications. But voice media has to be intercepted by 2007. That's their schedule. So they like to have RTP media. It's not because they're actually using it right now, but they have it in PSTN, and they want it for voice over IP too. And there's some call scenarios where it's really hard to get that data. So you still have to push the government or the Bundesnetzagentur to figure out that there are call scenarios which are easy to intercept. Like if some call goes to a PSTN gateway and you've got your equipment in place on the PSTN side, you can just use the equipment you have. Then you might have some calls which are coming into your network on specific points. But on the other hand, you might have calls, like I mentioned, between Australia and the US, where you don't have access to the media. And there's no way they can redirect the traffic without having the users notice, both in delay and in IP traffic itself. It would just be seeable. And if you're doing a distributed voice over IP setup, like you've got multiple POPs, multiple PSTN gateways, connections to other peering partners, you've got probably in multiple countries, and your zip system's just growing larger, you're going to have lots of hardware. And if you're talking about media, you've got lots of media proxies, and signaling in most setups can be done by just a few boxes, but if you have to take care of media and probably be so-called called stateful, it just doesn't work. And the other thing is, if you have to be able to copy the voice data, your law enforcement agency have to have everything in place to actually take the data. Since if you're like on a 2 megabit line and you're pushing like 100 calls to that, it doesn't work. I won't talk about the requirements on the law enforcement side, but it might lag at some point. But they have to do lots of things, and hopefully they will agree on just knowing that they're not able to intercept a few calls, but probably take other means to intercept those calls and make our life as an ISP easier, and on the other side make their life easier, since it's probably easier for them to make sure that nothing was left out or something in the process, since that's another thing that you have to make sure. You have to be able to copy 100% of the data, not just 99%. So that's one of the bad things that you have to do. So what's going to happen next? All the laws apply to ISPs that have more than 1,000 customers. But if you're talking about World of Warcraft, you've got like a voice chat feature, or in Counter-Strike or whatever. But if you've got an online service that charges you to use the service, and one of the services they offer is actually voice chat, they are a voice ISP, and they might have to comply with the very same laws. So they might be able to send voice chat from like a computer game to the law enforcement agency. And it might be a totally different protocol in signaling and media, but it might be on their list. And if they are treating everybody the same way, they probably have to. So the next thing is Vorratsdatenspeicherung. It's been done on email and stuff, and it's planned on email, and you probably have to do the very same for voice over IP calls. Like just doing call logs, like you've got on your Einzelverbindungsnachweis that you get with your bill, like who did you call on which day, how long did it take, and the amount you have to pay. So we might have to store all the data and provide that to the government later on. And there's a European law that's going to be passed, and depending on the country, like France, the UK, and Spain, enforce their companies to store data for 3 years, but Germany said, okay, we're just going to do the bare minimum of 12 months. But it's up to the ISPs, and it might kill smaller ISPs that just have enough customers, so they have to comply to the laws, but they cannot afford to build a huge data warehouse to store all the data. So that might be really bad. And some of the resources, like the RFC I've mentioned before, it deals with all the so-called handover interfaces, like management, signaling, and then media and all sorts of stuff. And it has all the abbreviations that is used in, that are used in most papers, and especially Cisco stuff. Then you've got the Bundesnetzagentur website, which used to be the RecTP. It now has a really funny name. And I couldn't directly link to the slides, but if you go to the Bundesnetzagentur website, on the upper left side, there's a link to the voice over IP stuff. And they actually have statements from all ISPs, all the questionnaires that they got back with all the things. There are a few things marked out, but you can still read them. And it's easy. It's interesting to see what ISPs are actually doing right now and what they were doing like half a year ago in terms of signaling. And then this is my website. The slide's going to be up there sometime tonight. So yeah, just go there for the slides and probably more information. So any questions? Okay. You should probably get.
Is there an emerging standard regarding voice over IP encryption?
Okay, the question was if there's any standard on voice over IP encryption. Voice over IP is signaling and media, and signaling has to be really one standard, since if you're doing signaling within your own ISP, it might be easy, but if you're doing voice over IP peering, like peering between like WebDE, Freenet, Zipgate, all those companies, you have to agree on a standard, and there's TLS. But the downside on TLS is that it's just based on TCP. And you're just not able to keep all the file descriptors open, to keep all the TLS sessions for all your customers. If you're talking about 6 or 7 digit numbers of customers, it's not doable. But there's something called DTLS. I just came across this a few weeks ago. It's TLS for datagrams. So you can use TLS on a UDP-based setup. And what I'm going to look into, since I'm really interested in that, is how DTLS actually works, and if it's a feasible way to do TLS for customers. Since if you're using TCP, the call setup times would just increase. You have to do the TCP handshake, since you might have lost your TCP connection in the first place, and if you're trying to save file descriptors on the server side. And I think DTLS might actually be a way to do encryption on signaling side, and like SRTP could be good for media, but at every point we are talking to like an IVR machine, your voicemail box, doing some sort of announcement, or going to a PSTN gateway, that particular box has to be able to decode the data, and has to have the like certificates, and has to have the CPU power to actually do everything. So one of the few reasons why ISPs are generally not doing encryption is just due to the CPU power. You can have like 500 parallel calls on a small Cisco box, but if you're talking about TLS and SRTP, it probably goes down to like 50 or 100 calls and just doesn't pay off. So there's a few interesting boxes that have TLS accelerator cards in there, and using Asterix, you might be able to do that faster, but it's not being done right now. And the moment somebody pops up with something that they can actually do the same amount of calls with encryption, we're going to have a look at that. So any other questions? Okay, then thanks for your time.